Students, today we discuss graphical representation of motion in kinematics. First we discuss distance versus time graphs. So in these graphs, distance is taken on y-axis and time is taken on x-axis. So let us discuss different situations for distance versus time graphs. First one is rest position. So if you observe, the rest position graph is a line parallel to the time axis. Second one is uniform speed. Here the graph is in the shape of a straight line passing through the origin. So the slope of the distance time graph gives velocity. Third situation, an object is moving with non-uniform speed and speed is increasing. For this, distance time graph is a curved line like this. And next one is non-uniform speed with decreasing speed. For this, distance time graph is in the shape of a curved line. For non-uniform speed with speed increasing, the curve is a curved upward curve, whereas for non-uniform speed with speed decreasing, the curve is downwards. That is the difference between these two curves. And also in these two graphs, the slope gives the instantaneous speed. If you observe this graph has two straight lines like this. In this part of the graph tells about the object moving with uniform speed away from the starting point. Here the slope is positive. Slope is also called as gradient. Whereas this part of the graph B, it tells about object moving with uniform speed towards the starting point. If you take the graph of object thrown upwards, when an object is thrown upwards, it reaches the maximum height and again it comes back to the earth. So the graph will be like this. This is the distance time graph for freely falling body. If you observe, for a freely falling body, the graph will be a curved line with a negative gradient. Now we discuss velocity time graphs. So in these graphs, velocity is taken on y-axis and time is taken on x-axis. Now for the uniform velocity, there is a straight line parallel to the time axis, and for uniform acceleration with positive slope, we get a straight line passing through the origin. In velocity time graph, slope gives the change in velocity by change in time, that is acceleration, whereas the area covered under velocity time graph gives the distance covered in the time interval. Now this is the graph for non-uniform acceleration. If you observe, straight line for uniform acceleration, whereas a curved line with positive gradient for non-uniform acceleration. Here this is the graph for velocity time graph for uniform retardation, negative slope and straight line. So this is the graph for non-uniform retardation. If you observe, this is a curved line and having negative slope. Now this is a special case for an object thrown upwards. An object thrown upwards which moves with constant deceleration and moves again with, after reaching the maximum height, it comes back to the ground with constant acceleration. That's why we get a straight line like this. Now we discuss acceleration time graphs. In the same manner, here acceleration is taken on y-axis, time is taken on x-axis. For uniform acceleration, we get a straight line parallel to the time axis, and for non-uniform acceleration with constant jerk, we get a straight line passing through the origin. So the slope of the acceleration time graph gives change in acceleration by change in time. It is also called as jerk or jolt. Jerk or jolt is defined as the rate of change of acceleration. So jerk is denoted by J is equal to delta A by delta T. So the SI units of jerk are meter per second cube. This is the acceleration time graph for non-uniform retardation with constant jerk. Again, this is the acceleration time graph for non-uniform acceleration with varying jerk. See, acceleration means slope is positive. For uniform, we get a straight line. For non-uniform, we get a curved line. Similarly, this is the graph for non-uniform retardation with varying jerk.